Good afternoon. It is Thursday, October the 22nd. Today in geometry, we looked at section 3.5, which talks about proving lines parallel. If you remember, when we started this chapter, we assumed lines parallel and used them to prove different types of angles were congruent. So in section 3.5, we're turning around and going backwards. We are given that the angles, the types of angles, have the properties that we talked about. And what we have to do is prove the lines are parallel. So I'll share the screen here and show you a couple of problems that deal with this. So the first thing, if you look in your book on page 205, you have what is called the converse of the corresponding angle postulate. And what this postulate says is if the corresponding angle, so let me draw you a situation here. If you have two parallel lines here, and they're cut by a transversal. So in this case it says if two lines are cut by a transversal and the corresponding angles, so let's say this angle here would be angle A, this here would be angle B. So the converse to the corresponding angle postulate says if these two angles, these two corresponding angles are equal, then the lines are parallel. Now we're going to use that then to show that, okay, like if we have angle C up here and angle D down here, these would be alternate exterior angles, and we will have a theorem that says if the alternate exterior angles are congruent, then the lines are parallel. Or we could say that if we get angle E right in here, then we've got angle B and angle E, which are alternate interior angles. So we have a theorem that will say if the alternate interior angles are congruent, then the lines are parallel. And then the next one would be like if we put angle F right in here, you know that F and B are consecutive interior angles, and if angle F and angle B, if the sum of their measures is equal to 180, once again, then we have a theorem that says that the lines will be parallel. And the final thing says that if I take this line right here, let's see if I can take this line and pull it. Nope, I can't pull it. Okay, so I'll draw a different, let's undo all this until we get back to the two original lines. Now, so the last theorem that we says if we have one line, if we have two lines that are perpendicular to the same line, so if this line here, we have this one perpendicular and this one perpendicular here, if those two lines are perpendicular to the same line, then they will be parallel. So let me, once again, I'll undo this and I'll show you a couple of problems that we looked at here. So if I have two lines, let's say we have two lines here, we have a second line here, two lines are cut by a transversal, and then we have let's say this angle here is 5x plus 7. So we got 5x plus 7 for that angle. And then we have this angle down here, which is 7x minus 21. Now, these angles are alternate interior angles. So the question is, okay, what does the value of X have to be in order for the two lines, let's call this line L and this line M. So what does the value of X have to be for line L to be parallel to line M? Now they are alternate interior angles, and we know that if they are equal or if they are congruent, then the two lines are parallel. So we'll come up here and we'll set our equation. We set them equal. So we have 5x plus 7 is equal to 7x minus 21. And then we do a little algebra here. We take the 21 across to the left, so that gives us 7 plus 21 is 28. And we subtract the 5 from the 7, so equals 2x. And that gives us, if we divide both sides by 2, that gives us x equals to 14. So if x is equal to 14, then I have those two lines, L and M, are parallel, okay? Now, a different type of problem here. So if we undo all of this, once again, remember you can pause the video and look at something or run it back if you don't understand what we did. So I'm going to draw, once again, the situation I'm going to draw now. We're going to get 4 different lines. So we got one here. Get these wide enough. So this is one. And then we'll have another line coming across like this. And we'll have a 4th line coming across like this. So now, and then we're going to go in and we're going to number all these angles. So this would be angle 1, 2, 3, 4. And we go around here, we go 5, 6, 7, and 8. And we come down here to the lower left and we go 9 through 12. So that'd be 9, 10, 11, and this would be 12. And then the last one is 13 through 16. So we got 13, 14, 15, and 16. And then we label our lines. So we're going to let this line here be M. Line M. This is line L. And the top 2 lines, this is line B. And this is line A. So now if I look over here, okay, let's say I have angle 2 is congruent to angle 8. So I get my congruent symbol to angle 8. So the question is, which 2 lines does this prove are parallel? So if I look here, here's angle 2, here's angle 8. They are alternate interior angles for line A and B. So that proves that A is parallel to B. Now you can kind of work these problems out, because if you look, see when I look at angle 2 and 8, line M here has nothing to do with angles 2 and 8. So I can't come over here and say that the fact that angle 2 is congruent to angle 8 does anything to control line M. So therefore, I can't say here that L is parallel to M, because these 2 angles don't do anything to M. So that's kind of a way to think your way through this when you look at a particular type of problem. So let's say now we have angle 8 is congruent to angle 16. Okay, now in this case, if you look, See, angle 8 and 16 are corresponding angles. And once again, see, line A here has nothing to do with angle 8 and angle 16. So I can't put A and B parallel, but I can put L and M parallel. So if angle 8 is congruent to angle 16, then line L is parallel to line M. So these are the types of problems that we did in this section. Now we'll spend another day on this section tomorrow. I'll go ahead and close out here. If you look at your schedule, the test on chapter 3 will fall next Friday. So we will be working on reviewing between now and then, but tomorrow we will spend one more day on section 3.5. So if you look at your homework problems, if you have questions, send me an email and I will get back to you and explain it to you. So that will be all for now.